Good day, I am Mary Grace Villarda.
I am Edric D. Agagan,
And we are here to discuss the zeroth law of thermodynamics. Based on the other three laws, zero thermodynamics law is formulated. Still, at the time of discovery, lots of confusion occurred about the naming, whether to name it as the fourth law or something else. This confusion got sorted as a clear definition of temperature and its occurrence. Hence, it is named as the zeroth law of thermodynamics. So what is zeroth law of thermodynamics? The zeroth law of thermodynamics begins with a simple definition of thermodynamic equilibrium. It is observed that some property of an object, like a pressure and a volume of a gas, the length of a metal rod, or the electrical conductivity of a wire, can change when an object is heated or cold. If two of these objects are brought into physical contact, there is initially a change in the property of both objects. Eventually, the change in the property stops and the objects are said to be in thermodynamics equilibrium.
Thermodynamic equilibrium leads to a large-scale definition of temperature. When two objects are in thermal equilibrium, they are said to have the same temperature. During the process in reaching thermal equilibrium, heat, which is a form of energy, is being transferred between the objects. The details of the process in reaching thermal equilibrium are said to be being described in the first and second law of thermodynamics.
The zeroth law of thermodynamics states that if two thermodynamic systems are both in thermal equilibrium with a third system, then the two systems are both in thermal equilibrium with each other. So now, Edric will conduct an experiment for our easy understanding.
And today, I'll be explaining the concept of the zeroth law of thermodynamics through a simple experiment. For the materials we needed, we have prepared 3 containers, such as one for the hot water, one for the cold water, and one for the tap water, and 3 thermometers, and lastly, the timer. Immediately, I record the temperature of each container. It is said the hot water is 40 degrees Celsius, the cold water is 6.6 degrees Celsius, and the tap water is 28.5 degrees Celsius. So since the hot water and cold water container are in the tap water container, so let us start the time. So after 5 minutes, the temperature is now 30.5 for the hot water and 14.5 for the cold water, and the tap water is 28.1 degrees Celsius. So after some time, recorded again the temperature of each container. So the temperature shows that all containers have the same value of 28.3 degrees Celsius, achieving what is called an thermal equilibrium. But how did this happen, knowing each container, hot and cold water, are separate from each other?
Oh my gosh, my coffee is already cold. I don't want to drink this anymore.
Have you experienced this kind of situation? Well, I will explain it to you. Why does hot coffee become cold when you do not drink this within a few minutes? Well, I will explain to you how the zeroth law of thermodynamics is responsible for this. So the hot coffee is surrounded by the cold air of the room. The hot coffee loses its heat to the surrounding air of the room. This hot coffee will keep on losing the heat until its temperature becomes equal to the temperature of the surrounding air of the room. Let us say the surrounding is 25 degrees Celsius and the temperature of the hot coffee is 70 degrees Celsius. Then the hot coffee will lose its heat until its temperature reaches 25 degrees Celsius. In other words, the coffee will lose its heat until it achieves the thermal equilibrium of the surrounding. Thus, the zeroth law of thermodynamics appears here in this example of hot coffee.
Oh my gosh, your body
is very hot. It reaches 40 degrees Celsius. It means that you have a high fever. A thermometer in contact with your body is an example of zeroth law of thermodynamics. So let me explain to you why. There is a mercury inside a glass tube of thermometer. Now, when a thermometer comes in contact with a hot body or a person having a fever, its temperature rises. But how much will be the temperature rise in a mercury? Now, this is a big question. The mercury will rise up to the temperature of a human body which is in contact with it. After a few seconds, this mercury and the human body will be at the same temperature. Thus, we can say that they are thermal equilibrium with each other. When the temperature of the mercury increases, it expands. And due to this expansion, the level of the mercury inside a glass tube will rise. And we can come to know about the temperature of the human body through the readings marked on the thermometer. And that is how the principle of thermal equilibrium or the zeroth law of thermodynamics appears here in thermometers. Thank you for watching!